Okay, so again, we are talking about the consistency, and here we are talking about the type of consistency because in the system design problems, in the system scales, depending upon the need, you might need a different kind of consistency because every kind of the strict behavior got some compromises with it, and comes with some compromises on other side. Okay. So you balance things and match the thing according to your need, according to your systems. Where is the balance? So you can compromise on one thing, then you can get more on other side. So when we talk about the CAP theorem, then you will understand like what exactly I'm talking about. Because there is other term availability you might have heard, and that availability things is the compromise we get. The consistency when we want more consistency in the distributed system, but for now your availability term might sound jargon to you, like what is availability. You might have some basic sense, but in the distributed systems you need to have a clear picture, just like the consistency we have talked about with examples, with the concepts, exactly what is consistency mean and what is availability means. Then you, after knowing those two, then you will be able to understand with a clear picture that what is CAP theorem is talking all about, and what is the trade-off I'm talking about. But for this video, let's stick with the type of consistency because it will give you the eventual step-by-step understanding of these terms. Okay, so let's start with the type of consistency. First type of consistency is the strong consistency, which is the ideal. Where is the case I've shown you in the previous video? Like you want all of your data to be synced across all of your user, all of the devices around the world at the same time. Example is the bank. In the bank, you don't want any transaction to be shown or reflected after some delay. Either you want not to happen and it should reflect overall around the world, or you want to happen, then it should show across all the users. Of course, the users which are related to that transaction, not all. It is public. I'm not talking about the publicly, shown that transaction, but yeah, you get the idea what I'm talking about. So if you have a balance of 100 rupees, then your bank and the account you are transferring, both these three parties should know the exact same balance, not exact balance, exact same transaction details, because they are the concerning parties. So this is the strong consistency, which is the normal consistency we are talking about, the ideal case. The second is the eventual consistency. So sometimes you don't want that hardcore, the ideal consistency, but you can compromise with the eventual consistency. Eventual consistency means that suppose if you have you have seen it in the real world, like if you post something on LinkedIn or any platform and media, and you have a lot of followers, then you sometimes it happens that for some users it's shown like as immediately as possible, and for some they it took some time, like few seconds or few minutes even. Same like same with YouTube. If you post a YouTube video, then for some users they are showing immediately on the channel, but for the some users take time. So it is not predictable like how other companies like YouTube and LinkedIn or social media implemented it, like and where they implemented exactly. But the purpose we are here to understand, like why we need a eventual consistency. And first answer is that if some system is okay with eventual, means it not at the same time, but it might take some time, but eventually it will become consistent over all the systems. So it means that if you have post something, then eventually after some time, 10 minutes, one day, then all of your user device will be synced up with the same post. So it is consistent, but eventually after some time. Examples. So suppose some, again it happens in the e-commerce websites sometimes, that if something goes back in stock, then eventually after some time, if you refresh the page, or if you don't refresh, then if it is a real time, then after sometimes all of your users will see that product get back to the in stock, and you can order that. So there are many examples, and because it is just simply understand where we use this in the case where we don't need that hardcore real time consistency, where we can okay with the delay, some delay, but we still want the consistent data. We don't want that data to be juggled around. Yeah, you can, some users can see the past 2 day data and somebody past one, and then some users see the latest data, and that is not consistency means. Then eventually also means that it should be depend upon the system, what time, what delay they can expect that they can absorb. Let's move forward with the next type of consistency, which is causal consistency. So the causal consistency is simple, like some kind of data updates or read is depending upon some other. So suppose if you want to be synced with the B, but B is dependent upon A. So first A need to happen, and then B will occur, and then you can see the B. It will become very clear with the example. So suppose it might happen. You have might seen, it is rare, but you might have seen sometimes, hopefully, that if some YouTube video you have opened and suddenly you've seen sometime like the view are less than the likes. I don't know you have encountered to this scenario, but it happened. It has been witnessed that, yeah, if a YouTube video is very viral and very it is getting views very fast, and it is posted recently that the viral channel is posting videos immediately, and that videos are viewed by watched by many users, then sometimes it is noticed that the likes of the video which is more than the views, and that is the causal consistency, which means that causal inconsistency, because it is example of inconsistency. Because if someone has not viewed the video, then how can it like that video? Okay, so if causal consistency ensures that the consistency should be causal based. So if you have post, then only you might get the notification of comment on it, comment of those notification if some comment is there. So if you get the comment notification first and the post notification after that, then it is inconsistent, and that is the problem we are discussing about in this causal consistency. So if some system want to be causal consistent, then he should follow this kind of exact behavior. There are three more kind of consistent types we will talk about in this next video. So thanks for watching.